All right, here we go. We're going to do 6.6. The first thing I'm going to tell you, the title is called Approximating Indefinite Integrals. It is the Riemann Sum. And note, I am not teaching it like the book. So the book on 6.6 will not help you. You're going to get a worksheet to go along with this, and the worksheet will have what I want you to do in this sequence. So what you're going to try to do is you're still finding the area under the curve. So back in the day when I went to school, we didn't have fancy calculators, and so we had to do this by hand. So we decided that the area under the curve, so I tried to draw the green curve 3 times the same way. If you just found it straight across, the easiest way to find area is length times width, or area of a rectangle. So we decided, well, if you split it up into 2 rectangles, that would be a better estimate or approximate area of that. So I did it with 2 and there. And then someone said, well, what if you did it with 4 rectangles? So I split it up into 4 rectangles, the same curve, but into 4 rectangles, making it a little bit margin, a little bit air, that you wouldn't have this area, this little space, you wouldn't just have a smaller spaces in those spots. So, well, if it going from 4, what about 8? And 8 made even smaller areas that you didn't have spaces there. So the idea is the more times you split it up, which are going to be called subintervals, the better off your area will be. So if you want to take the time to pause the video and to make those, that would be that. So the 8 rectangles in this one would actually have the closer area or estimate to the area of the curve. So that's the idea. In theory, you're finding the area of the rectangles, then add each of the areas. So you find the area of, if we go to the 8, find the area of this rectangle and this and this and this and this and this and this and this, and add all 8 together, and you'd get it. So our first example, that's exactly what we're going to do. Okay? So if the diagram of interval from 0 to 10, this is called an interval, is partitioned to 5 subintervals. So that means I'm going to make 5 rectangles, and I'm going to make them from 0 to 2, 2 to 4, 4 to 6, 6 to 8, and 8 to 10. Now, first of all, you might say, well, how did I know that it was going to be intervals by 2? Well, 10 minus 0 divided by the 5, 10 minus 0 divided by the 5 is going to be your interval width. So that meant my width was going to be 2, the distance of 2. So that's how I found that. Anyhow, so I found by approximating the area, choosing a left endpoint. So when they say choosing a left endpoint, that means your rectangle left side is going to come out and come down. So technically, this is the shaded area of that rectangle. This is the space. In this one, it was fairly flat. That's the space that's going to be a little bit out. The left was still there. That's going to be the space out. Left here is from there to there, with this being the space. Left here is from here to here, and left here is from there to there. So there's spaces there unaccounted for, space there, all unaccounted for. But it was closest to it. So what I did is I said, well, where did this line come across to the y-axis? What was the height of that rectangle? Because height times width is going to be your area of the rectangle. So the height of this one was 6 times 2. So I wrote 6 times 2. The height of this one is 8 times the same distance, 2. 8 times 2. The height of this one is 7. And remember, I tried to draw these as best I could. 7 times 2. The height of this one is 3 times 2. And the height of this one is 4 times 2. And so then I put those all in the orange. 6 times 2 plus 8 times 2 plus 7 times 2 plus 3 times 2 plus 4 times 2. I decided to take the 2 out and add all the numbers together. 6 plus 8 plus 7 plus 3 plus 4 times 2. Inside was 28 times 2. The approximate area there is 56 units squared. That was from the left. Okay? We're going to talk about from the left and the right in a little bit, but right now we'll just leave it at that. So I'll give you a moment there to absorb what I just said. We are going to be able to use a calculator. So hopefully you brought your calculators today, or you will when you're at Hangout tomorrow. And you're going to see how to put it in the calculator. So this light blue is what it's going to go into the calculator. And the blacks are definitions of what each of them are. So the first thing, I would like you to write it down just as is. Parentheses, sum. Parentheses, sequence, SEQ. Parentheses, W, that's times. In parentheses, the function. If I had x squared plus 2x minus 5, you'd put x squared plus 2x minus 5 with on parentheses. Comma, which is above the 7. X, comma, the first side of the interval, the last side of the interval, and the width. Now, that's not totally correct, so let's talk about each after you have that written down. The first two things I'm going to talk about is where can you find the word sum in your calculator. If you hit second stat math sum, you'll get sum. So write that down, second stat math sum. The next word you need to find in the calculator is sequence. It's very similar. You do second stat. One of the other things is ops or options, sequent. So it's very similar. Second stat ops sequence. Now that W is the width. The width equals B minus A over N. B and A are like this one. It's 10 minus 0. Over the N is the number of intervals. And this one was 5 subintervals. So my W in this one was 10 minus 0 divided by 5. B minus A divided by N. N is the number of intervals. X is a variable in your calculator. Again, I said the commas were above the 7. The first, when you're going from the left endpoint, this is going to be very specific. It's the most left number. So the most left number on this one is 0. The most left first number, 0. The word last, if you're going from the left, is the left number in the last interval, or 8. It is not the last interval. It is the left last interval, or 8. I'll be showing you examples on the other page. Just get your definitions written down now. Now, what if you're going from the right endpoint? This first and last changes. Nothing else changes. Okay, so you'll still have sum, sequence, parentheses, with times function, comma, x, comma. Now your first is the right number in the first interval. So if we were doing this problem from the right endpoint, we would use 2, because 2 is the first number in the right number in the first interval. Last is the last number of all the intervals, or the right number of the last interval, 10 in this one. All right, now that's a lot of just words, but that's going to help you, because once you get that, you get to use your calculator and just punch it in the calculator. All right, let's go to some examples that you actually can do in your calculator. So I chose the first one to be fairly simple. I chose x squared. Approximate from 0 to 8 x squared dx. Do not do it in a calculator. Do not do it definite integral method. Do it like this. If I'm asking you to approximate the area, by dividing the intervals 0 to 8, notice that 0 and 8 are what's on the A and B there. Those are considered A and B, into 4 subintervals of equal length, and pick U at the left endpoint. All right, I'll give you a chance to write that down. All right, I wrote 3 steps down. Step 1, write these intervals down. Step 2, find the width. Step 3, place in the calculator formula. And if you can do those 3 steps each time, you'll be fine. So, the intervals. Well, the first thing you probably should do is maybe find the width. So the width is 8 minus 0 divided by 4 equals 2. So that distance between each of these has to be 2. So then I go 0 to 2, 2 to 4, 4 to 6, and 6 to 8. Typically, we write those in brackets. Now we're going to write it in our formula. On your quiz and test, this formula has to be written down as well as that answer. If you just give me an answer, I think you'll cheat it off as whoever. I don't know what. But right now you have to write that formula down on your paper every single time. Sum, sequence, oops, that should have been a parentheses, 2, because 2 is the width times the equation, x squared, unparentheses, comma, x, comma, now this is from the left, and the leftist most was 0. 6, because the left number on the last interval was 6, comma, 2, because that's the W or the width. Unparentheses, unparentheses. And if you stick that in your calculator, hit enter, and you should get 112 units squared. Note you should always have labels of units squared because we are talking area again. All right, we're going to do the same equation, but we're going to do it by dividing the interval from 0 to 8 into 4 subintervals of equal length and pick U as the end from the right endpoint. So the only thing in the directions changed is I said from the right endpoint. Now, because this is a curve, the right endpoint is higher than the left endpoint. I wrote my intervals, 0 to 2, 2 to 4, 4 to 6, 6 to 8. My W is 8 minus 0 divided by 4, or 2, and then I write it in my formula. Sum, sequence, parentheses, 2x squared. Because this is just an x squared, you did not have to have the parentheses on it, comma, x. Now this is where you changed. Note, change here. You're going from the right, so the right number in the first interval is 2. The right number in the last interval is 8. But the last number is 2 because that's the width. You punch in the calculator and get 240 units squared. Note, there is a huge difference in your answer. They are not definite, they are not defined, and it is not the exact answer. These are approximate answers depending on which side of the interval you went from. Be careful. Don't give me the exact, it will be counted wrong. All right. Speaking of, let's go to example 3. So in example 3, we're going to approximate the integral of x cubed minus 2x squared plus 12 from 0 to 12. By dividing this interval, these are just the directions, and really you have to look at a couple things. What's the interval width? How many subintervals, and which endpoint are you doing it? So we're going to divide the interval from 0 to 12 into 6 subintervals of equal length and pick U on the left endpoint. So 6 subintervals is more than we've done before, so it should become more accurate. Not perfect though. So I wrote my integrals out, 0 to 2, 2 to 4, 4 to 6, 6 to 8, 8 to 10, and 10 to 12. I found out my width. 12 minus 0 over 6 is 2. I write everything in my sequence formula. Sum, parentheses, sequence, parentheses, 2 times. This time you are required to use a parentheses because your equation is a long equation. X cubed minus 2x squared plus 12, unparentheses, comma, x. Left endpoint, left of the first is 0. Left of the last is 10. And the width is 2. And I get 2,864 units squared. A large number. But remember, this is a cubic and it's going to go on forever, and it's from 0 to 12. 12 would be way up there. I don't expect you to graph these, at least not with perfection. Part B, by dividing the intervals 0 to 12 into 4 subintervals. So this is less. So this is less accurate. Of equal lengths, and pick the U on the right endpoint. So I decided to go for the width. The width is 12 minus 0 divided by 4 is 3. So I'm going to get 0 to 3, 3 to 6, 6 to 9, and 9 to 12. Not the same as I did before. And I'm going from the right, so I'm going to sum sequence 3, the width, times the equation, x cubed minus 2x squared plus 12, on parentheses, comma, remember the comma's by this above the 7, x, comma, 3, because 3 is the right number in the first interval, 12, because it's the right number in the last interval, comma 3, because that's the width, and I get 6,624 units squared. Wow. Major difference. Okay. Your homework is going to be the worksheet 6.6, 1 through 5, and I'll attach that when I attach this to your Hangout or to your assignment. All right. So this is called Riemann Sums. It's finding approximate areas under curves by Riemann Sums rectangular method. That's all.